Thank you very much for joining us today. My name is Tim Winter. I'm a Managing Director in the Global Service Provider Group here at iDirect. Under my purview are some of our strategic accounts within the Global Service Provider Group, and I also lead the global defense efforts here at iDirect. iDirect's footprint throughout the global defense marketplace is significant. As you can see, 18 of 28 European Union member states embrace and use our technology, 16 of 29 NATO member states, and obviously the U.S. Department of Defense. Within the U.S. Department of Defense, we are close to 70% of the deployed SATCOM ground architecture. So once again, a significant footprint, not only in the U.S., but throughout the world, creates commonality and puts iDirect in a very beneficial position when coalitions operate together in operations throughout the world. The spectrum of military communication grows more complex every day. Advanced requirements, mobility, flexibility, dynamic reallocation of bandwidth, these needs present themselves with each new requirement. High-speed broadband is a hard requirement for many missions and security efforts. Advanced IP networks like those that are provided by iDirect are no longer a nice-to-have, but a must-have. Live video, HD, and ultra-high-definition live video provided by beyond line-of-sight ISR assets, whether aero or maritime or ground mobile, are key really to many of the, like I said, mission success elements throughout the world. Hub and terminals and antennas are the backbones of these networks. Today, we are going to go through these components, how they operate together, and provide sort of best-of-breed beyond line-of-sight satellite communication networks. These networks also have to be, as I mentioned, flexible and serve multiple mission sets. No government has endless money to include the U.S., and these networks got to be used for one mission one day and can be reallocated to other mission requirements the next. Over the next 2 years, we believe, according to NSR, that the military service market is to reach $10 billion globally. So by year 2021, $10 billion. $3.7 billion will be associated with high-speed communications on the move, or comms on the pause. You'll hear COTM, which is communications on the move, and COTP, comms on the pause. These requirements are growing every day, as I mentioned, with ISR assets and mobility needs in both maritime and land mobile efforts. So you see on the slide, mobility is key. Over 60% of revenue growth will come from UAVs, especially the proliferation of unmanned assets. Many countries have unmanned assets, both in ISR and other capability requirements in play. There you see the comms on the pause and maritime efforts. NSR has noted an 8% combined annual growth rate through 2026 in UAVs for ISR mission sets. As many of you know, the data gathering and the data transport is the requirements around those is very robust and will continue to grow. Terminals deployed by armed forces have risen by a 20% CAGR over the past 5 years, more than 45,000 terminals now in service. And we at iDirect see that growth will continue, like I said, especially as terminals get smaller and more capable and utilize satellites in multiple orbits. The proliferation of these terminals will continue. Okay, so today I want to walk through sort of our views on the modern defense network, some of the requirements and qualifying criteria, in other words, whether it be security or resiliency or robustness that these networks must meet. And then we'll talk about some higher efficiency and performance. I said that budget constraints and budget requirements will always be paramount in many efforts throughout the globe, and due to that, efficiency will always be near the top of new requirements and programmatic efforts. And then we'll go through sort of our broad defense portfolio and how iDirect, like I said, we currently have a dominant position in the marketplace, and how we plan to continue to add new capabilities to benefit the end user. And then we'll finish up with some seamless mobility experience and how important that is, as I mentioned, in both aero, maritime, and ground, land mobile efforts. Okay. Secure and resilient networks. First and foremost, no network is effective without security. If the approach to security is not sound, one's network can simply become a liability. This is certainly true. Hub and terminal remotes authentication have to be paramount, not only in the use of networks, but in the design of the networks. So both at the hub and the remote equipment and physical level. And validation will always be important. In TDMA networks, like those provided by iDirect, as many of you know, remotes are coming in and out of the network all the time. And there's greater opportunity because of this for a bad actor to come in and out of the network. They could spoof or insert a rogue remote terminal into the network. This obviously is not acceptable. And like I said, if this was the case and there was an open door as such, these networks would become a liability and a great opportunity for a bad actor. So to mitigate this risk, iDirect employs digital certificates, some of you are aware of, both at the remote and hub level to provide Transect. This is sort of our X.50509 digital certificate. I'm not going to get too far into the weeds here in the technical aspects of that certificate. But as many of you are familiar with it, it uses RSA public key crypto system. Two keys are created, a public and private. The private keys are used to encrypt the public keys. And like I said, they're generated at the NMS, so on the hub side, and then certifications exist on all remotes and NMS, and at the NMS, and on the Transect line cards. And hubs and NMS keep these certificates for each remote that are configured in the network. This sort of prohibits a rogue remote or an unknown remote from entering the network, which is a must-have. And our approach to security and resiliency has been has been adopted and well accepted by the end users that we currently support. Additionally, FIPS 140-2 Level 3 is paramount and is sort of centerline for all iDirect equipment and services that have been provided. This ensures that hardware obviously meets the FIPS standard. FIPS, for those of you who don't know, is the Federal Information Processing Standard. Really, the U.S. government and the Canadian government defined FIPS years ago. Level 3 applies a standard for physical tamper resistance. And once again, like I said, our equipment meets the FIPS 140-2 Level 3 Transect, which is really a must-have as bad actors and rogue states get more familiar with SATCOM networks. Okay, the satellite world is getting more complex. It's becoming more operationally efficient, more cost-effective, more capable, but certainly it is getting more complex. We've gone from geostationary satellites to geostationary high-throughput satellites to MEO constellations. Now we have LEO constellations that are on the horizon, and of course, ultra-high-throughput satellites are also coming. So, great news, a lot of capacity is coming online. We will be utilizing, we as an industry, as a satellite communication industry, will be utilizing multi-orbits to serve different end users, different applications, and different needs. Multi-orbits, as I mentioned, do support different applications, different mission sets due to different latency. Also, MEO, LEO create an additional security layer, you can imagine, where geostationary satellites are static, if you will, and positioned in the sky and could potentially be an easier target. LEOs and MEOs, not only are their constellations have multiple satellites, some being planned, north of 2,000 satellites, which create a almost natural physical security hedge, if you will, against those that want to penetrate those networks. But adversaries are getting smarter, so that's why capabilities like anti-jam, protected tactical waveforms, some things that you guys have heard, will be paramount in the development of both remotes and hubs in the future. And as I mentioned a few times already about budgetary constraints, carrier optimization, utilizing transponders in the most efficient manner will also be very important as multi-band and multi-orbit capabilities coexist together. So end users are going to need help. The satellite world, like I said, is getting more complex. It is getting better. The capabilities brought forth are exciting, but end users are going to need help sort of deciding what constellation or what capability best fit their mission needs. And part of these networks, obviously, just talk about the satellite constellation and the space assets. You know, these networks are becoming much greater integrated. The integration of these networks to glean out the efficiencies and capabilities lend itself to being a fully integrated network. In other words, the terminals have to be very integrated with the space assets and with the ground architecture. So iDirect is very excited about this. I want to walk through sort of a couple things that drive our thought process when developing and supporting our current defense-grade terminals. First and foremost, performance and efficiency. I talked about the excuse me. I talked about the need to be both cost-effective and operationally efficient. This will, with multi-orbit satellite constellations, you know, the end user, whether it be a foreign government or end user, will want to deploy the most efficient networks that they can and get the greatest use out of transponding capacity. Efficiency is very important for airborne ISR assets with large return lengths that require excessive bandwidth. So efficiency will always be paramount in the design of airborne terminals. Comms on the move, comms on the pause support. Not only aero and maritime assets, but land mobile assets want to operate in one region in 1 hour or 1 day, and then another region the next day. Obviously, airborne assets are going from beam to beam to beam continually, and that's got to be seamless transition. So comms on the move has to be seamless. We're talking make before break from going beam to beam, where there's no break in whether it's data collection, video delivery, where decisions are being made in real time. So that has to be supported on the maritime side as well. So once again, that's aero, maritime, and land mobile. It will be an imperative to support comms on the move and comms on the pause application. Mil standard 810 Golf, that's a follow-on from 810 Foxtrot. Once again, standardization, environmental capabilities operating in austere environments. These will be important as well. Some of these terminals are small, leave-behind terminals. It's not acceptable if they cannot operate in harsh environments, and standardization like Mil Standard and others that exist out there help drive not only the design but the support of these terminals and their operational capabilities. WGS certifiable. I'm sure all are aware of the WGS satellite constellation, and being RSTRAT certified or having the ability to operate on these satellites is very important. A lot of these nations have invested, those that are involved in WGS, U.S. and Five Eyes nations, have spent a considerable amount of money on the WGS constellation and need to ensure that the terminals that they deploy are not only operational on the WGS space assets. So iDirect, working with our terminal integration partners, always leans forward with assistance for WGS certification and support for their needs. Okay. Multiple form factors, including man-portable. As I mentioned, terminals are getting smaller. They need to be smaller. Terminals exist now the size of a laptop that are very capable, that challenge the size and form factor of BGAN-like terminals, but can provide higher data rates. And once again, this is driven really by the high throughput capabilities, HTS capabilities of the current satellite constellations, and those that are coming in the future. They will all enable terminals to be smaller. Okay, greater power, smaller spot beams will enable smaller form factor terminals. to include those that utilize FPAs or flat panel antennas, and the use of electronically steered antenna arrays that are coming in the very near future. So it's very exciting. Once again, the new satellite constellations are really enabling sort of a growth of greater form factor man-portable terminals. So it's an exciting time. Optimized swap, that is related, somewhat related to man-portables, and smaller, lighter is always better. Power consumption, these are always concerns with designing and providing the best defense-grade terminals. And I want to go back to multiple form factors. Configuration management for many governments is important. In other words, they want commonalities between the ODUs, the outdoor units, for their defense-grade terminals that are very similar, let's say, across a family of terminals that they might employ. So whether they have a 60 centimeter, 96 centimeter, 1 meter, 1.2 meter, 1.8, they want operational commonalities, not only for support, but for training and for operational employment. So that's very important as well. Mobility experience. So as mentioned, a lot of the growth in the coming years and coming decade will be driven on mobility, ease of operation throughout the world. Like I said, many governments and users want to know that their units can come in and out of any network, anywhere in the world, and next week maybe do it seamlessly somewhere else in the world. So that's one layer of the seamless experience. The other one is very tactical. In other words, aircraft going beam to beam, not having any break in connectivity, maritime assets the same, and fast-moving ground assets. So this speaks to ease of operation, coming in and out of network, like I said, without challenge, and it's becoming a qualifying criteria. In other words, they must have to operate within these new global HTS constellations that provide global managed network services that governments can utilize, whether it be an Intelsat Flex or Global Express or SES or Speedcast. They all provide a sort of a global managed network product that does fit into some of the needs and requirements of global governments throughout the world. Let me touch on a few of these items that are mentioned on this slide. Automatic beam switching, I mentioned that. A lot of these ISR, manned and unmanned airborne assets have to operate between beam to beam to beam. They're fast movers. They go through a beam very quickly. And a lot of their data that they are exfilling or transmitting off the platform is very important to intelligence and what I call high leadership decisions, and any break in connectivity is really not acceptable. So this is sort of a make before break capability. And with multi-orbit satellite constellations coming online, this has become even more important as assets can operate between a GEO, a MEO, and a LEO to perform different mission capabilities. Even the same asset might be doing something different each day, whether it be a data collect that can be time delayed and can use a a GEO HTS satellite, or something that requires lower latency, in which case they might want to use a LEO satellite. But this is what our future could look like. Global NMS and tracking. As I mentioned, many service providers and satellite owner operators have established global networks. So, the end user wants to be able to track each terminal with a consistent IP address, not only to monitor its status, but ensure a high-quality connection throughout the globe. So tracking is important, knowing where those assets are, and obviously ensuring that there's a high-quality connection no matter where they are operating throughout the world. Open AMIP protocol, obviously, is an antenna modem interface protocol. This is very important to airborne and beam switching and maritime assets. This facilitates, this standardized protocol facilitates exchange of information between the antenna and satellite router. So common interface has helped terminal integrators take our modem architecture and marry it, if you will, to their antenna control unit and antenna, forming a seamless sort of terminal experience. And because it's a standard, it allows us to interface with many integrators more easily than not. So it's good. We're getting away from sort of bespoke terminals, one-off networks, and really embracing standards that are allowing us to move forward, like I said, with many terminal integrator partners. Fast beam switching and beam switch API. So we talked about no break in service. We talked about beam switching. We talked about the really make before break. That's sort of our next bullet here. Capability, where connectivity is not dropped. We obviously want to enable APIs as well, allowing customers and users to design different ways of extracting data from terminal sets and from the network while operating from beam to beam. And then, so that's a make before break as well. So dual DMON capabilities, make before break. In other words, it really can be, the terminal can be, connected to two beams at one time and facilitate a handover from beam to beam without breaking connectivity or data transmission. Fast reacquisition, if a break does happen, and this is a very challenging problem set with aircraft moving 600, 700 knots. It is a challenging, like I said, scenario, and so breaks, it will be understandable that breaks could happen for any number of reasons, and if that happened, there needs to be a fast reacquisition capability so the terminal can re-enter the network automatically on its own, which is very important, without user assistance, and bring that asset back online. ACM, or Adaptive Coding and Modulation, Adaptive TDMA. This speaks to efficiency. Adopting the latest coding and modulation techniques allow the networks to be very efficient. And efficient drives cost effectiveness, and it also increases operational efficiency by allowing the transport of higher data rates. When we start talking about HD video and ultra high definition video, which is, like I said, very commonplace and in high demand and will continue to be so through many military efforts and global government efforts, this type of coding and modulation is very important. And adaptive TDMA, allowing the network to operate as efficiently as possible, but if there's weather or other sort of variables that are driving the use of certain coding and modulation standards or approaches, the network can almost self-heal and be very adaptive to use the most efficient coding and modulation available at any given time, but have the capability when to know that closing the link and keeping the link closed is paramount, and so the network needs to use the modulation that achieves that. Advanced quality of service. This allows end users to manage bandwidth across an entire fleet globally to prioritize service levels based on multiple criteria. Even though there's lots of capacity online now and more capacity is coming, like I said, there are cost constraints and there are operational constraints, and governments want to know they can use hardware and software that allows them to apply quality of service across multiple terminals to allow them the most efficient operation of their network. Spread spectrum. For those of you who know, this diffuses high signals to minimize ASI, or adjacent satellite interference. A lot of these airborne and maritime assets have small terminals that need to utilize spread spectrum for the return link. So because of power limitations, so they do not interfere with adjacent satellites. This is more prevalent in KU band, as there are more KU band satellites. But this will be ASI, or satellite interference will be a growing concern as multi-orbit satellites and satellite constellations come online. So It's very important to have such a capability to utilize more bandwidth, less power in this case, to transmit data off of these platforms. High-speed comms on the move feature. Like I said, this is a difficult problem set. Jet aircraft are moving at, you have to deal with high Doppler rates, high speed, and the ability to maintain connectivity in the satellite network, especially when going from small high-throughput satellite beam to small high-throughput satellite beam, can be significant. So that is a challenge, and our hardware, need to ensure that your hardware and software are capable of meeting that challenge. And then security, we've talked about security, AES encryption, military-grade transect, we've talked about FIPS standards, but standards are important going forward, and everybody has to, and we feel it's very important that iDirect complies to those standards, include those standards, adopt them, and making sure that our equipment is part of the most secure, or as secure as possible, satellite network. Okay. Now I want to go into sort of our iDirect product portfolio. We're going to talk about sort of what we have organically, and then I'm going to take a couple of minutes and talk about sort of our breadth and reach into our ecosystem, known as our partner integrator ecosystem, and which is mostly terminals, but I want to touch upon that as well. So defense-grade products. So at iDirect, we have defense-grade products and commercial products. I'll spend a few minutes talking about each. These products can operate together, depending on how the network is designed and implemented, but they provide different capabilities that might need different mission sets for any global government. First, on the hub and line card side, we have a tactical hub, which is obviously much smaller than our normal hub, our infrastructure. It's very cost effective. The tactical hub has a single DLC T line card. So it has one transmit line card, one receive line card, and like I said, it has a very small footprint. So it's compatible with with any of our defense remotes. We talked about FIPS standardization and security. It's the 140-2 level 3, and MIL standard 810 Gulf. So cost effective, small footprint. It can meet many mission sets and support smaller, more tactical networks, I would say. But it's a very nice product, and has been very effective. The defense line cards, so the transmit receive, they support DVB-S2 and S2X. On the transmit side, the receive can be demodulate up to 16 channels. Once again, full transec, 140-2 level 3 on the FIPS side, and can support evolution and velocity-based networks. We haven't spent a lot of time talking about evolution and velocity, but those are two of our platforms that are both being utilized in global government requirements and needs. On the remote side, we have the 9 series, which many of you are familiar with. The rack mount and board would be 9350 or 950. This has DVB-S2 with ACM and ATDMA return capability on velocity. 8-port gig E switch that is on the 9350. And obviously the 950MP, much smaller form factor, perfect board level product for MANPACK, man portables. Like I said, the trend is for smaller terminals, smaller footprint, reducing swap, and the 950MP is a great product to support those initiatives. Security obviously baked into the remotes as well. There's the 140-2 level 3 Transag 810 Gulf, and WGS certified. So many of our terminal integrator partners utilize these boards within their terminals for use on WGS. And these remotes support both evolution and velocity-based networks. On the aero side, we have the 980, 9800, which is available on the board, rack mount, and air ink enclosure. This supports obviously ultra-high speed, comms on the move, aero applications. It does have a second DMOD, so that second DMOD can support multicast overlay or beam switching. We talked about the importance of seamless beam switching, but that second DMOD can also be used for multicast overlay, so a secondary network, if you will. In addition to the security characteristics we already discussed, this also is DO-160G. For those of you that are in the aero vertical, you're very familiar with that. These are also certified for use on WGS and hold R-Strat certification. These remotes, like the others, will operate on evolution and velocity-based networks as well. On the commercial side, let me quickly go through server hub and remotes that are available on the commercial side. So on the hub, I'm sure most are familiar with our universal hub architecture. This is capable of DVB S2 as well as S2X, S2 up to 45 mega symbols on the out, S2X up to 119 mega symbols. This is available right now on Evolution for S2X. That's coming in the coming year for Velocity. MONCOD's up to 256 APSK, so very efficient. We talk about the importance of being efficient. That is a very efficient MONCOD for the network user. An ATDMA on the return up to 29 mega symbols, up to 16 channels once again on the return, 16 QAM, so we're talking about very efficient return. Like I said, MONCODs, which will support efficiency not only on the transmit side outbound, but also on the return. 16 QAM is coming in Evolution primarily, or is first, and that'll be this summer, and then it will be followed shortly thereafter for that capability on Velocity. Now I'll talk about the IQ remote, the IQ remotes. So the IQ desktop series, desktop is a small, for those of you who have not seen, it's a very small modem. There's a desktop form factor. What you see there is the IQ desktop and the IQ desktop plus giving you sort of an additional sort of environmental capability. But these support both S2 and S2X with ATDMA returns. They're very efficient, small form factor, desktop, commercial grade modems. Now, look, the IQ series, like I said, it's a commercial grade product. It's not going to last in harsh environments, very austere conditions that require advanced environmental capabilities and ruggedization. That's not really what these are designed for. They're a commercial level product. However, but they do have, they're very good products. They're deployed through all sorts, throughout the world for commercial needs and capabilities. And they might, like I said, they have attractive price points, and they might fit certain mission sets and requirements for global governments. So let me just go through the IQ200 quickly. The IQ200, once again, we view this is being adopted on the maritime side commercially. And like I said, it could be a potential solution for global government for, well, I guess, lower grade maritime operations. But also supports S2, S2X, 2 gig E ports. Like I said, it's got the mobility function where the IQ Desktop does not bring that. The IQ Desktop is for commercial applications, static commercial applications. IQ200 brings mobility in both of the Evolution and Velocity. IQ LTE series, we're very excited about this product. This obviously combines VSAT and 4G LTE capabilities in a single box. This is coming very soon. It's a rack mount product. We're looking at ruggedizing this and making a defense level IQ LTE product in the future. But we think for disaster recovery and response, those that go somewhere, deploy somewhere, and might have the ability to use LTE, but are unsure whether the LTE networks are operating, this could be a great product, because if LTE is a no-go, then they could hop on a satellite network with the auto switchover. You also have the opportunity with a product like this of running two separate networks that provide different capabilities. In other words, you could run something over an LTE network, and then you could also have an overlay of the SATCOM network to perform or provide different capabilities. Okay, AGILIS MANPACK, I'm going to talk about, we could spend all day talking about all our partners and the many terminals that they have. We'll touch quickly upon that. But AGILIS is an organic product for ST Engineering, our parent company. They have a very, what I would say is a best-of-breed MANPACK product. It is available in the 1 meter and 1.2 meter, and you see the weights there, 33 kilos for the smaller and 39 for the larger. This is a 2-backpack packaging, so it still has a very small footprint. Fast deployment with an auto-acquire functionality. You're talking less than 8 minutes from setup to being acquired on the satellite network. And, you know, as everybody wants to move towards everybody being a communicator, what I mean by that is as global governments deploy their forces, they have a primary mission set, but they want all of their soldiers, airmen, or seamen to also be a communicator, be capable of putting up a system like this. And this is this is a system that lends itself to ease of operation, ease of commissioning and installment, and it does help with that mindset of sort of every soldier, sailor, airman being a communicator. So A10F, A10 Foxtrot, which is just a precursor of A10 Golf. There's really not too much difference between Foxtrot and Golf. Compliance for the environmental is there, temperature, humidity, precip, vibration. So ruggedized solution, MANPACK, this certainly can operate in austere locations and harsh environments, and it's a very good product that's been well received throughout the global government market. And like I said, this is an auto-pointing, one-touch acquisition button. Very easy that positions this product for ease of operation, and then acquires through a DVB beacon receiver selection on the terminal. The 9050OM. So this is a newer product for iDirect. It's basically an external ODU modem that has our 950 MP board. This is a very ruggedized modem and casing. The 9050 can be submerged in water for a significant period of time and still operate and still be very effective. So if you have a chosen antenna set or an ATU and need just an external, very ruggedized modem, that could also be used from terminal to terminal to terminal. This could be a great product that could meet your needs. Like that's ruggedized, passively cooled, so it's quiet. We're not talking any fans here. All the LEDs can be blacked out, so it can operate in a clandestine manner. Let's see, its data interface is a single data input-output connector to support 2 LAN ports. Console, it's got a transmit key line, so you're conserving power, and it does have a GPS input. Has an external power supply that's designed to meet the same protection requirements as the enclosure. So once again, ruggedized, you really can use this anywhere in the world. You can use it from antenna to antenna to antenna if you're talking about configuration management, and you have 1.2, 1.8, or 1 meter antennas, let's just say, and want a modem that can be used from antenna to antenna. This could be a great product for you. Okay, the KYWAY U7 terminal. I'm sure many have seen the KYMETA antenna that's been everywhere and anywhere. It certainly is a niche product, but it has its place, and there are very many attractive features of the KYMETA antenna, and in this case, the KYWAY U7 terminal, which utilizes the iDirect X7 modem set with the KYMETA antenna for a fully integrated bundle solution. Now, once again, I mentioned sort of niche products, so you're talking maritime. It is a passive array. Land mobile form factor is very good. It is easy to set up, easy to use. You will be limited on data input or data throughput, it being a flat panel, but it's a very effective product, and its use and interest is growing really throughout the globe. So no moving parts. Once again, we talked about the ease of operation, ease of commissioning. Has flexible installation options, whether we're talking maritime or land mobile. Does provide a broadband capability. It's low on the power consumption, which is always attractive, and can provide secure connections. So, glow in the swap, very attractive form factor. It has its limitations, some network limitations certainly, but a very effective product, both the maritime and ground mobile This is also an example of iDirect working with some of our partners throughout the world, in this case Kymeta, but as many of you know, whether it's Tampa or Cubic or L3, all the terminal integrators that we work with, we're very intimate with their terminals, and greatly assists with their terminal design integration on the land mobile, and then Astronics on the aero side and other partners as well. So, in conclusion, iDirect is very pleased with our position and footprint within the global defense space. As mentioned, we have a significant amount of content with NATO nations, EU nations, and obviously the U.S. Department of Defense. Looks like exciting days are ahead in the satellite communications world. Multi-orbit satellites are going to bring forth additional capabilities, not only driving down price point, making these capabilities more affordable to governments throughout the globe, but also bringing forth greater capabilities that will enable smaller terminals, greater comms on the move capabilities with seamless acquisition, enabling networks to come in and out of network, or to enable terminals coming in and out of networks with very little human or manual engagement. And so it's an exciting time. So this was a brief sort of introduction of our defense product set. Obviously, we are always working on next gen and what's coming next, and we're excited to be doing that. We're very excited to be working with our terminal integrators and helping them create best-of-breed products that fit into not only today's global government marketplace, but those that are in the very near future. So we enjoy collaborating, growing our ecosystem. And once again, our goal is to be the online site communication partner to those throughout the globe. We want to be there to consult, to provide end-to-end solutions, to bring forth content from our partners, both on the terminal side and those that own and operate space assets. And we think there's a lot of value creation for and by iDirect for global government customers.